Okay. My next check is independence. So within the sample, those observations need to be independent of each other, which is why I said no consulting in making your airplanes. And the two samples that we had have to be independent. So we don't want to get into the situation where we're doing matched pairs. Matched pairs is not done with a two sample procedure. Matched pairs are done with a one sample procedure. So if we think we have a connection between this 2.1 and this 3.75, then we may be in matched pairs. Since our sample sizes are different, we're probably not, we don't have any problem here. They're not matched pairs. But when sample size get to be the same, we need to kind of think about how your data was collected were the two samples totally independent of each other. Okay. Next part, the math. I need a test statistic. My test statistic will be, let's see, I did males greater than females. So that'll be the mean, sample mean for the males minus the sample mean for the females minus the hypothesized population mean of the males minus hypothesized population mean for the females. That would be 0. That would be 0, right? Yeah. Yeah. All right. Standard deviation or standard error is different. I need the sample standard deviation of the males. I have to square that because I'm going to add two standard deviations together. And when I do that, I have to add their variances. Divided by the sample size of the males plus the standard deviation for the females, get the variance of that, square that, divided by the sample size of the females. Now let's get my numbers here. The males were 2.3625. Are these numbers right, Charlie? I noticed you put those in your calculator.
Yeah, they're right. I checked them.
Okay. 1.927 minus 0 divided by square root of 1.568 squared. Sorry. Divided by 13 males plus 1.434 squared divided by 12 females. And I don't know if I have that number anywhere. .7253. Okay. That sounds right. I did find my number and I wrote down 0.72. So we're good. So far we're good. What else do I need in my step 3 besides a test statistic? P-value. To get my p-value, I need my degrees of freedom. Well, which n? If you're conservative, you take the smaller n. and get 11 degrees of freedom. If you are, there is another process for finding degrees of freedom that your calculator actually does for you automatically. And you can use that calculation also for degrees of freedom. Doesn't matter which one you use. Yes, the calculator gives you a non-integer value. You can look up the formula for that one. It's kind of fun. All right, so my p-value, now let me think. I'm looking at my distribution here. I got 0.72. I'm looking at males being greater than females, so I'm looking at the right side of this distribution. So I want to do a T-CDF from 0.72 to positive infinity with degrees of freedom of 11. And what do I get for a p-value? 0.24. All right, ladies, what do you think of this p-value? What do you think? Yay! You're supposed to go yay. It's a good one. The women are supposed to go yay. Oh, okay. Okay. All right, now, since our p-value of 0.24 is greater than any reasonable alpha, we fail to reject the null hypothesis. Therefore, what's my therefore? We do not have evidence. Yes, there's no significant evidence. Yes, we do not have evidence that.
This very questionable test.
We're going back to that caution, proceed with caution. Is that what we're going to do? Should we take Jody's out and see what happens? Not going to do it. Fine. All right. So there we go. There's a 2 sample. Now, because you are pretty sophisticated, we will do the confidence interval right at the same time because you can now go back and forth between significance tests and confidence intervals fairly quickly. All right, so if I'm going to do my confidence interval, I'm going to estimate the difference between EN, male and female made, airplanes differences. Whoops, distances. Okay, and I should say at this point which direction I would like to find the difference in. You could do males minus females or females minus males. So let's do, since we were thinking that males were making better airplanes, I'm going to do the mean of the males minus the mean of the females, where mu sub m is the average distance of male-made planes, just like before.
Taking out the outlier turns P to 2.085.
Oh, still pretty high.
Still fine.
Yeah, yeah, all right, good. I'm happy to hear that. Ah.
Shave off like 15%.
So our confidence